Welcome back, UPSC aspirants. Every year, geography contributes 4 to 6 questions in UPSC prelims, and a significant chunk of those come from just one chapter, Evolution and Interior of Earth. Today's video is built on a concept-first approach. That means I won't just throw facts at you, I will help you truly understand these concepts, so that no matter how UPSC twists the question, you can crack it. So without wasting any more time, let's get started. Let's begin with the very first question: how was the Earth formed? Earth is approximately 4.5 billion years old. When it first formed, it was a barren, rocky, and extremely hot object. It had a very thin atmosphere composed only of hydrogen, H, and helium, He. Now, let's understand this through a timeline. 13.7 billion years ago, the Big Bang. This is the starting point of the entire universe. A massive explosion gave birth to space, time, matter, and energy all at once. 5 to 6 billion years ago, formation of stars. As the universe cooled, clouds of gas and dust collapsed under gravity to form stars. 4.6 billion years ago, formation of planets. Our solar system, including Earth, was formed from the leftover material around our Sun. 4.4 billion years ago, formation of Moon, the Big Splash. A Mars-sized body called Theia collided with the early Earth. The debris ejected from this massive collision came together to form the Moon. This event is known as the Big Splash, and it is a UPSC favorite fact. 4 billion years ago, formation of oceans. Volcanic eruptions released enormous amounts of water vapor into the atmosphere. This vapor cooled, condensed, and fell as rain, eventually forming the oceans. 3.8 billion years ago, life begins to evolve. The first primitive life forms appeared in the oceans. 2.53 billion years ago, evolution of photosynthesis. Cyanobacteria evolved the ability to perform photosynthesis. This was the critical turning point. Oxygen began to be produced for the very fire. Evolution of Earths. From a UPSC perspective, there are three major systems that evolved on Earth: the lithosphere, the atmosphere, and the hydrosphere. Let's break down each one. 1. Evolution of the lithosphere. Differentiation. Here's what happened inside the early Earth. Due to gravitational compression, Earth's density increased and its internal temperature rose dramatically. As a result, heavier materials, iron and nickel, sunk toward the center. Meanwhile, lighter materials, silicates, rose toward the surface. This process is called differentiation, and it gave Earth its distinct layered structure. Crust, mantle, outer core, inner core. Think of it like this: if you mix sand and oil in a glass of water and shake it, the oil floats to the top and the sand settles at the bottom. That is exactly what happened inside the early Earth. 2. Evolution of the atmosphere. 3 stages. Stage 1. Loss of primordial atmosphere. The earliest atmosphere consisted of hydrogen and helium. However, solar winds were so powerful that these light gases were completely blown away into space. Stage 2. Degassing. As the Earth slowly cooled, volcanic eruptions released gases from its interior. These gases, nitrogen, N, carbon dioxide, CO, methane, CH, and ammonia, NH, formed the second atmosphere. This process is called degassing. Stage 3. Photosynthesis. Early life forms developed in the oceans. When photosynthesis evolved, around 2.5 to 3 billion years ago, oxygen began accumulating in the oceans. By approximately 2 billion years ago, free oxygen flooded the atmosphere. UPSC trap alert: many candidates assume that the early atmosphere was oxygen-rich. That is completely wrong. Free oxygen appeared much later, only after photosynthesis evolved. This misconception was directly tested in the UPSC 2018 question, where statement 2 was incorrect because the early Earth had no significant oxygen. 3. Evolution of the hydrosphere. Volcanic outgassing. Continuous volcanic eruptions released large amounts of water vapor into the atmosphere. Cooling and condensation. As Earth's temperature decreased, co-dissolved in rainwater, enhancing further cooling. This led to repeated condensation and prolonged rainfall over millions of years. Ocean formation. Rainwater accumulated in surface depressions, forming oceans by approximately 4 billion years ago. That's within just 500 million years of Earth's formation. Moving along. Part 2. Inside the Earth. How do we know what's inside the Earth if we've never been there? Earth's radius is 6,370 kilometers. The deepest hole ever drilled by humans reached only 1 kilometer, the Kola Super Deep borehole in Russia. That's less than 0.2% of Earth's radius. So we cannot directly observe the interior. That's why scientists rely on 2 types of evidence. Direct sources: surface rocks, deep sea mining, Emponing gold mine, 3.9 kilometers deep, volcanic eruptions, and drilling projects. Indirect sources, seismic waves, gravity anomalies, magnetic field behavior, and meteorites, which formed from the same nebula as Earth and gave us clues about Earth's bulk composition. Structure of Earth layer by layer. Layer 1, the crust. The outermost and thinnest layer of the Earth. Depth 0 to 70 kilometers. State rigid and brittle. Density 2.7 to 3.0 gcm superscript 3. Two types of crust. Continental crust made of granitic rock, rich in silica and aluminium called Ciel. Oceanic crust made of basaltic rock, rich in silica and magnesium called Sima. Key comparison: oceanic crust is thinner, denser, and younger than continental crust. Volume: only about 1% of Earth's total volume, the thinnest shell. Layer 2, the mantle. Extends from Mohorovi, Moho, discontinuity to 2,900 kilometers deep. State: solid but plastic, behaves like a solid under sudden stress but flows slowly over long periods. Density: 3.3 to 5.7 gcm superscript 3. Composed of silicate rocks rich in iron, Fe, and magnesium, Mg. Repeti discontinuity marks the transition between the upper and lower mantle. Lower mantle is more stable and less involved in plate tectonic activity. Volume: 84% of Earth's total volume, by far the largest layer. Layer 3, the core. The innermost region, divided into two parts. Outer core. Separated from the mantle by the Gutenberg discontinuity. Extends to 5,100 kilometers depth. State: liquid, temperatures of 4,000 degrees C are too high to maintain a solid state. Density: 9.9 to 12.2 gcm superscript 3. Composition: Fe, nickel plus iron. The movement of this liquid Fe generates Earth's magnetic field through the geodynamo effect. This is extremely important. Inner core. Separated from the outer core by the Lehman discontinuity. Extends to Earth's center, 6,370 kilometers deep. State: solid despite even higher temperatures, extreme pressure keeps it solid. Density: 12.6 to 13.0 gcm superscript 3, the densest layer of Earth. Composition: Fe, nickel plus iron. Total core volume, 16% of Earth's total volume. Globe with meridians. Other key concepts you must know. Lithosphere. Crust, both continental and oceanic, plus the rigid uppermost part of the mantle is equal to 10 to 200 kilometers thick. It is broken into massive slabs called tectonic plates, the origin of earthquakes and volcanic activity. Asthenosphere. The upper portion of the mantle, 100 to 200 kilometers deep. Also called the plastic layer, it is semi-fluid, highly ductile, and viscous. It is the source of magma and is driven by convection currents within the mantle. The D-double-prime layer. A critical heat transfer layer near the core mantle boundary. Mantle plumes are theorized to originate here. Isostasy. The gravitational equilibrium between the Earth's crust and the denser plastic mantle, asthenosphere, below, where the crust floats at different elevations depending on its thickness and density. Think of it like an iceberg floating in water. A thicker iceberg rises higher above the surface. Shape, size and abundance of elements. Let's now talk about the shape and size of the Earth and the elements that make it up. Shape: Earth is not a perfect sphere. It is a geoid, also called an oblate spheroid. This means it is slightly flattened at the poles and bulging at the equator due to the centrifugal force generated by rotation. Earth's radius is approximately 25 kilometers smaller at the poles than at the equator. Size: Earth is the fifth largest planet in the solar system. And importantly, it is the densest planet in the solar system, approximately 5.513 gcm superscript 3. Abundance of elements in Earth's crust. Oxygen 46.6%, silicon 27.7%, aluminium 8.1%, iron 5.0%, calcium 3.6%. UPSC note: oxygen is the most abundant element in Earth's crust, not silicon. This catches many candidates off guard. However, in terms of the entire Earth's composition, iron is the most abundant element, 34.6%, because the core is largely made of iron and nickel. Okay, let's zone out back to the surface. Part 3: mapping the globe. Latitudes and longitudes are imaginary lines used to determine the location of a place on Earth. They form a systematic grid on which any surface feature can be precisely represented. Latitudes, parallels. Latitude is the angular distance of a point north or south of the equator, measured from the Earth's center. Key properties. 1 degree of latitude is equal to approximately 111 kilometers, 69 miles. This distance remains constant everywhere on Earth. The linear distance of a degree of latitude at the pole is slightly longer than at the equator. Only the equator is a great circle. It passes through Earth's center, divides it into two equal halves, and represents the shortest path between 2 points on Earth. All other latitudes are small circles. What is a great circle? A circle passing through the center of the Earth and dividing it into two equal halves. It represents the shortest path between two locations on Earth's surface. The equator is the only latitude that qualifies, all other parallels are small circles. Important parallels to remember. Equator 0 degree only great circle latitude, equal day and night year round. Tropic of Cancer 23.5 degree N Sun is directly overhead on 21st June, summer solstice. Tropic of Capricorn 23.5 degree S Sun is directly overhead on 22nd December, winter solstice. Arctic Circle 66.5 degree N midnight sun begins here. Antarctic Circle 66.5 degree S midnight sun in southern hemisphere passes only through Antarctica. India specific, the Tropic of Cancer, 23.5 degree N, passes through 8 Indian states, Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. Longitudes, meridians. Longitude is the angular distance east or west of the prime meridian, 0 degrees. The prime meridian passes through Greenwich, UK, France, Spain, Algeria, Mali, Burkina Faso, Togo, Ghana, and Antarctica. Key properties. The distance between meridians is greatest at the equator and decreases toward the poles, converging to 0 at the poles. All meridians are considered great circles when paired with their opposite, antipodal, meridian, for example, 0 degrees and 180 degrees. Next part 4 Mastering time zones. The Earth completes 360 degrees of rotation in 24 hours. That gives us 15 degrees of longitude is equal to 1 hour, 1 degree of longitude is equal to 4 minutes. Directional time rule. Moving eastward add time, gain hours. Moving westward subtract time, lose hours. Local time versus standard time. Local time is determined by the sun's exact vertical position over a specific meridian. True noon varies at every meridian. Standard time is a uniform time adopted for an entire region or country to avoid administrative confusion. It is generally chosen in multiples of 7 degree 30 of. Longitude. Indian Standard Time, IST. Based on the 82 degree 30 East Meridian. IST is equal to GMT plus 5 hours 30 minutes. The IST meridian passes through 5 states, Uttar Pradesh, Madhya Pradesh, Chhattisgarh, Odisha, and Andhra Pradesh. In Korea district, Chhattisgarh, the IST meridian, 82 degree 30 E, intersects the Tropic of Cancer, 23 degree 30 N. Due to India's 30 degrees longitudinal span, there is a 2-hour difference in Sunrise between Nagaland, east, and Jaisalmer, west. International Date Line, IDL. Follows the 180 degrees meridian through the Pacific Ocean. Zigzags to avoid splitting a single landmass or island group across two different calendar dates. Date change mechanism. Crossing west to east, Asia to Americas move the calendar backward by 1 day, repeat the day. Crossing east to west, Americas to Asia move the calendar forward by 1 day, skip a day. UPSC 2025 case study Anadyr versus Nome. Anadyr, Russia, and Nome, Alaska, are geographically very close to each other, but they are separated by the IDL. As a result, Anadyr is 21 hours ahead of Nome. When it is Monday morning in Anadyr, it is Sunday morning in Nome. Countries with the most time zones. France 13 time zones. Russia and USA 11 time zones each. United Kingdom and Australia 9 time zones each. Denmark and New Zealand 5 time zones each. Brazil and Mexico 4 time zones. Let's roll into part 5 motions and season. Earth's two primary motions. Rotation. Rotation is the movement of the Earth on its own axis, from west to east, completing one full rotation in 24 hours. Earth's axis makes an angle of 66.5 degrees with its orbital plane, or 23.5 degrees with the perpendicular to the orbital plane. What would happen without rotation? Half of the Earth would remain in permanent darkness and freezing cold, while the other half would be scorched by continuous sunlight. Consequences of rotation. Day and night, the circle of illumination divides Earth into the lit and dark hemispheres, creating the cycle of day and night. Coriolis force, a pseudo-force that deflects winds and ocean currents. To the right in the northern hemisphere. To the left in the southern hemisphere. This is known as Ferrel's law and it governs the direction of cyclones, trade winds, and ocean gyres. Geoid shape, centrifugal force from rotation causes the Earth to bulge at the equator and flatten at the poles. Tidal effects, rotation contributes to the timing and frequency of tides. Extra depth for mains aspirants. Earth's rotation rate is gradually slowing down due to tidal friction, the gravitational pull of the sun and moon continuously dissipates Earth's rotational energy. Mass redistribution, as polar ice melts and glaciers retreat, mass shifts toward the equator, increasing Earth's moment of inertia, which slows rotation. This is similar to a spinning figure skater extending their arms, they slow down. Polar wonder and axis drift, Earth's spin axis, has shifted nearly 4 meters since 1980. Revolution. Revolution is Earth's movement around the Sun in a closed elliptical orbit. Time taken, 365 days, 5 hours, and 48 minutes. This extra time accumulates to give us a leap year every 4 years, adding 1 extra day to February. Orbital extremes. Perihelion, 3rd January. Earth is at its closest point to the Sun, approximately 147 million km. Insolation is slightly higher. Axial tilt, obliquity. Earth's axis is tilted at 23.5 degrees relative to the perpendicular of its orbital plane, or equivalently, at 66.5 degrees with the orbital plane itself. Without this tilt, there would be no seasons anywhere on Earth. Day and night lengths would be equal globally year-round. Milankovitch cycles. Earth's axial tilt varies between 22.1 degrees and 24.5 degrees over a 41,000-year cycle. These long-term orbital changes, including orbit shape and axis wobble, are collectively called Milankovitch cycles, and they influence the intensity of Earth's ice ages. Solstices and equinoxes. Solstices occur when the Sun reaches its highest or lowest point in the sky at noon, resulting in the longest and shortest days of the year. Equinoxes occur twice a year when the Sun is directly over the equator, making day and night nearly equal in length worldwide. Now let's understand the 4 important positions of the Earth during its revolution around the Sun. First, the summer solstice, which occurs around 21st June. On this day, the Sun is directly overhead at the Tropic of Cancer, located at 23.5 degrees north latitude. The northern hemisphere receives maximum sunlight, resulting in the longest day and shortest night of the year. At the Arctic Circle, the Sun remains visible for a full 24 hours. Next comes the autumnal equinox, around 23rd September. The Sun is directly overhead at the equator. Both hemispheres receive equal amounts of sunlight, so day and night are nearly equal everywhere on Earth, each lasting about 12 hours. Then we have the winter solstice, around 22nd December. The Sun is directly overhead at the Tropic of Capricorn, located at 23.5 degrees south latitude. The northern hemisphere receives the least sunlight, leading to the shortest day and longest night of the year. At the Arctic Circle, there is continuous darkness for 24 hours. Finally, the vernal equinox, around 21st March. Once again, the Sun is directly overhead at the equator. Day and night become equal across the globe, with approximately 12 hours of daylight and 12 hours of darkness. Together, these 4 key events explain the changing seasons and variations in the length of day and night throughout the year. And finally, remember that Earth functions as one interconnected system. The core generates the magnetic field, the atmosphere protects life, the surface supports ecosystems, and Earth's rotation and revolution distribute solar energy. Together, these components make our planet habitable and create the climate patterns we experience every day. We've covered all the important concepts. Now comes the most important part, applying them in actual UPSC prelims questions. Pause the video when a question appears, try solving it yourself, and then compare your approach with the explanation. This is where real learning happens. Let's start with question number 1. Consider the following statements. Statement 1. The Earth's magnetic field has reversed every few 100,000 years. Statement 2. When the Earth was created more than 4,000 million years ago, there was 54% oxygen and no carbon dioxide. Statement 3. When living organisms originated, they modified the early atmosphere of the Earth. Now the question is, which of the statements given above is or are correct? Your options are: Option A, 1 only. Option B, 2 and 3 only. Option C, 1 and 3 only. Option D, 1, 2 and 3. Take a moment. Think about each statement carefully before I reveal the answer. Answer: Option C, 1 and 3 only. Statement 1 true. Earth's magnetic field does reverse periodically. This is called geomagnetic reversal and is proven through rock studies. Statement 2 false. The early Earth had no free oxygen. Oxygen only appeared around 2 billion years ago through photosynthesis. So 54% oxygen is completely wrong. Statement 3 true. Early organisms like cyanobacteria performed photosynthesis and released oxygen, permanently changing the atmosphere. Answer C, correct. Question 2 UPSC Prelims 2025. Consider the following water bodies. Lake Tanganyika. Lake Tonle Sap 3. Patos Lagoon. Through how many of them does the equator pass? Option A, only 1. Option B, only 2. Option C, all the 3. Option D, none. Think about where each of these water bodies is located on the world map. Option D, none. Lake Tanganyika, located in Central East Africa, lies south of the equator at around 3 degrees S to 8 degrees S. Lake Tonle Sap, located in Cambodia at around 12 degrees N to 13 degrees N. Patos Lagoon, located in southern Brazil at around 30 degrees S to 32 degrees S. None of these water bodies are on or near the equator. Answer D. Question 3, UPSC Prelims 2018. Among the following cities, which one lies on a longitude closest to that of Delhi? Your options are: Option A, Bangalore. Option B, Hyderabad. Option C, Nagpur. Option D, Pune. Remember, this question is about longitude, not latitude. Think about the vertical position of each city on the map. D. Answer: Option A, Bangalore. Delhi is at approximately 77 degrees E longitude. Bangalore 77.6 degrees E closest heavy check mark. Hyderabad 78.5 degrees E. Nagpur 79.1 degrees E. Pune 73.9 degrees E. Bangalore is almost on the same meridian as Delhi, despite being far south. Answer A. Question 4, UPSC Prelims 2025. Consider the following countries: United Kingdom, Denmark, New Zealand, Australia, Brazil. How many of the above countries have more than 4 time zones? Option A, all the 5. Option B, only 4. Option C, only 3. Option D, only 2. Think about which countries are geographically vast or have overseas territories that stretch across many longitudes. Answer: Option C, only 3. UK 9 time zones due to overseas territories. Denmark 5 time zones, includes Greenland and Faroe Islands. New Zealand 5 time zones, includes Pacific territories. Australia 9 time zones, but standard UPSC classification counts it differently here. Brazil exactly 4 time zones, not more than 4. 3 countries, UK, Denmark, and New Zealand, clearly have more than 4. Answer C. Question 5, UPSC Prelims 2025. Consider the following statements. Statement 1, Anadyr in Siberia and Nome in Alaska are a few kilometers from each other, but when people are waking up and getting set for breakfast in these cities, it would be different days. Statement 2, when it is Monday in Anadyr, it is Tuesday in Nome. Which of the statements given above is or are correct? Option A, 1 only. Option B, 2 only. Option C, both 1 and 2. Option D, neither 1 nor 2. This is about the international date line. Think carefully about which side of the ideal each city falls on, and what happens to the date when you cross it. Answer: Option A, 1 only. Statement 1 true. Anadyr, Russia, and Nome, Alaska, are separated by the international date line. Anadyr is 21 hours ahead of Nome, so at breakfast time they are on completely different calendar days. Statement 2 false. When it is Monday in Anadyr, it is Sunday in Nome, not Tuesday. Nome is behind Anadyr, not ahead. Answer A. Question 6, UPSC Prelims 2025. Consider the following statements. Statement I, scientific studies suggest that a shift is taking place in the Earth's rotation and axis. Statement 2, solar flares and coronal mass ejections bombarded the Earth's outermost atmosphere with tremendous energy. Statement 3, as the Earth's polar ice melts, the water tends to move towards the equator. Which one of the following is correct? Option A, both 2 and 3 are correct, and both explain statement I. Option B, both 2 and 3 are correct, but only 1 explains statement I. Option C, only 1 of 2 and 3 is correct, and that explains statement I. Option D, neither 2 nor 3 is correct. Answer: Option B, both correct, but only 1 explains statement I. Statement 2, true, but it does not explain the axis shift. Solar flares affect Earth's magnetic field and atmosphere, not the rotational axis. Fact only. Statement 3, true, and it does explain statement I. When polar ice melts, water redistributes toward the equator, increasing Earth's moment of inertia and causing the axis to shift. Fact plus explains. Both statements are factually correct, but only statement 3 explains statement I. Answer B. Question 7, UPSC Prelims 2024. On 21st June every year, which of the following latitudes experiences sunlight of more than 12 hours? Equator. Tropic of Cancer. Tropic of Capricorn. Arctic Circle. Option A, 1 only. Option B, 2 only. Option C, 3 and 4. Option D, 2 and 4. Answer: Option D, 2 and 4. 21st June is the summer solstice, longest day in the northern hemisphere. Equator, always exactly 12 hours. Not more. Tropic of Cancer, sun is directly overhead, gets about 13.5 hours of daylight. Tropic of Capricorn, southern hemisphere winter, gets only about 10.5 hours. Arctic Circle, midnight sun, 24 hours of daylight. Answer D. Question 8 UPSC Prelims 2022. In the Northern Hemisphere, the longest day of the year normally occurs in the Option A, first half of the month of June. Option B, second half of the month of June. Option C, first half of the month of July. Option D, second half of the month of July. Answer, Option B, second half of June. The summer solstice falls on 21st June every year, and 21st June is in the second half of June. Second half starts from 16th June. That's the longest day in the Northern Hemisphere. Answer B. Question 9 UPSC Prelims 2019. On 21st June, the sun. Option A, does not set below the horizon at the Arctic Circle. Option B, does not set below the horizon at the Antarctic Circle. Option C, shines vertically overhead at noon on the equator. Option D, shines vertically overhead at the Tropic of Capricorn. Answer, Option A. Option A, true. On 21st June, the Arctic Circle, 66.5 degree N, experiences the midnight sun. The sun never sets. Option B, false. The Antarctic Circle has 24 hours of darkness on 21st June, not midnight Sunday. Option C, false. The sun is overhead the equator only on equinoxes, 21st March and 23rd September, not 21st June. Option D, false. The sun is overhead the Tropic of Capricorn on 22nd December, not 21st June. Answer A. Question 10 UPSC Prelims 2013. Variations in the length of daytime and nighttime from season to season are due to Option A, the Earth's rotation on its axis. Option B, the Earth's revolution around the sun in an elliptical manner. Option C, latitudinal position of the place. Option D, revolution of the Earth on a tilted axis. Answer, Option D, revolution on a tilted axis. Rotation causes day and night to exist, but not there. Seasonal variation. Elliptical revolution affects distance from sun slightly, not day length variation. Latitudinal position determines how much variation a place experiences, not the cause of it. Revolution on a tilted axis, because Earth's axis is tilted at 23.5 degrees, as it revolves around the sun, different hemispheres receive different amounts of sunlight, causing longer days in summer and shorter days in winter. Answer D. And that, my friends, is a complete, concept-driven walkthrough of Chapter 2 Evolution and Interior of Earth. Every major concept, every key fact, every UPSC trap, we covered it all today. If you found this video helpful, please like it and subscribe to the channel so you never miss an upcoming UPSC geography video. Drop a comment below which concept confused you the most before watching this video. I read every comment and I'll make dedicated videos on the toughest topics you mention. And remember, UPSC is not a sprint. It's a marathon. Stay consistent, stay concept driven, and you will get there. Good luck and keep going.